Hi to everyone. School of Engineering, Department of Mechatronics Engineering, online classes. Department Mechatronics subject. Analog devices and circuits, unit number 1. Myself, Saravanan, assistant professor in Mechatronics department. So this is the course objective and outcome of this analog devices and circuit. We have this is the syllabus. We have 5 units. So first unit basics on the based on the analog electronics. Unit number 2 based on the operation amplifier and its applications. Unit number 3 based on the waveform generators and IC. Unit number 4 measurement devices. Unit number 5 display devices. So in this in this class, we are going to discuss about the analog electronics unit number 1. Okay, there is a basic introduction for these analog devices and circuit. So in this circuit, so we are going to study about the switching devices, rectifiers, regulated power supply, switching power supply, and then feedback amplifiers and oscillators. Okay, these are the basic analog electronics we are used in the day-to-day life. So we are going to see about the characteristics of these devices as well as the different applications of these analog devices. Okay, so let's do the chapter 1. So in chapter 1, we are going to discuss about these different switching devices. Okay, that is ACR and triac. Okay, already we know that ACR in the basic functions. That is ACR is a silicon controlled rectifier switch. Okay, that means it is transfer one state to the another state with the particular time period. Okay, because most of the circuits it will be changed with the fraction of microseconds or milliseconds. So we need a different concept. That means we are going to enable the circuit and disable the circuit. So this is the concept of ACR. Okay, so ACR having the two characteristics. One is forward conducting characteristics, another one is reverse blocking characteristics. So ACR can be used in the high power devices. For example, the central processing unit of the computer, the ACR used as the switch mode power supply. The diode, it is a combination of two Schottky diodes. So it is another type is UJT. It is also used the efficient switching devices. So these are the basic formats. That is silicon control rectifier. That is our semiconductor controlled rectifier. We can call it two types. So SA is the parent member of the Thyristor family and is used in the high power electronics. So basic structure of the ACR will be, there are two models. One is PNPN or NPNP. That is effectively blocks current through the two terminal until it is turned on by the small signal at the third terminal. The ACR has two states. One is high current, low impedance state, that is called on state. And one is low current and high impedance state, that is off state. The basic transistor stash in the 4-layer. This is the basic symbol of the silicon control rectifier. That is, we have 4 junctions. Sorry, 4 formats, that is PN, and another one is PN. So these 4 generate the 3 junctions. That is junction 1, junction 2, and junction 3. That is one end is anode end. Another one is cathode end. Another one is G, that is gate, that is controlling the current flow through the PN junctions. Okay. So this is the VA characteristics of the SCR. The physical operation of the SCR can be explained clearly with reference to the current voltage characters. The forward bias condition and reverse bias condition illustrate the conducting the state and the reverse blocking state respectively. Based on these two states, the IV characteristics of the SCR will produce. That is depend on the forward blocking and reverse blocking. So after particular breakdown voltage, it will be conducted again in the forward condition. So already we discussed this, the high impedance forward state and low impedance and forward connecting state. So this is the forward bias and reverse bias condition. So let's see the power supply given to the anode and cathode. It is defined the bias between the circuits. If you are giving both positive and negative to the particular terminal, there is for the same term means that is called a forward bias. If we are giving different polarity means it will be a reverse bias circuits. So this is the simple applications of the ACR. Generally, ACR used in the many applications such as high powers of electronic switches, power control and the conversion mode process. So that is used as the static switch, power control, surge protection, power conversion like that. It is the another switching circuit, that is track AC switch. So that is the term tracks derived by the combination of the first three letters of the word from triad and the word called the AC. So the track is capable of conducting in both directions. So that is called a bidirectional thyristor with the three terminal. It is widely used for the control of power in the AC circuits. Okay, it is simply shows like this. This is the model of the triad, that is MT1 and MT2 terminal, and then is gave a gate terminal. Triad having following advantages. They can be triggered with the positive or negative polarity voltages. They need a single heat sink of slightly large size, as well as they need a single phase for protection. Which simplifies the construction. In some DC applications, the SI has to be connected with the parallel diode for protection against reverse voltage, whereas a track may work without a diode. A safe breakdown in either direction is possible. The tracks have low DVDT rating compared to the SCR. This is the main disadvantage of the track. So that is rate of change of voltage with respect to the T, that is time period. So it is actually, it should be in a square waveform. So square but the rate of change of voltage will be varying, means it is look like this. It is not a perfect square. It is nearby the square. So the rate of error will be increased. So that is the trigger can be direction circuit needful careful for the consideration. That is trigger அப்படிங்கிறது நமக்கு வந்து we need to use as a careful consideration, as well as the reliability of track is less than the ACR. The reliability of the track will be less than the ACR. That is the main disadvantage of the track. So these are some applications of track in speed control of single phase AC series or universal motors, in food mixers and portable drills, in lamp dimming and heating control, in zero voltage switched AC relays. Okay, so these are the different switching circuits used in the most of the power supply circuits. So in these two circuits, we are done through the transistor model. That is, we are done through the PN junction model. So it is having some noises. For reducing this process, we go for the field effect transistor. That is JFET and MOSFET like that. So that is also used as the switching devices for the most of the circuits. Okay. Okay, next class we will see the JFET and MOSFET. Thank you.